So we've established how to do problems like A. Let's go ahead and show you. We take this power and divide it by 4. We go ahead and go all the way with the problem until we get a remainder. And in this case, our remainder is 3. So that implies that the answer is negative I. Again, that's an I, not a 2. This is a negative I. For part B, we'll need to go ahead and figure out what I to the 122 is first. So, of course, we divide this by 4. 3, 12. Oh, the remainder is 0. The answer is 1. No. Finish the problem. Bring down the 2. That's a 0. Because it won't go in. The remainder is 2. If the remainder is 2, my answer is negative 1. But this problem also has a minus 1. So this negative 1 came from us simplifying I to the 122nd power. That became a negative 1. But then there's a minus 1 over here. So if we go ahead and combine these two, we get negative 2 as the answer for part B. Remember, A was negative I, B is negative 2. Don't mix up the I's with the 2's. Part C gets fascinating. So we're doing a couple of algebraic things here. First, we do 4 times 6, which is 24. Next, we're multiplying powers. So when I multiply powers, I add them. 6 plus 7 is 13. So that's I to the 13th power. But what is I to the 13th power? Well, we can go ahead and do this quickly. Divided by 4. I get a remainder of 1. If I have a remainder of 1, then it's just going to be an I. So what happens is I can actually replace this entire thing and just put I. So this is equal to 24I. But Mr. Over, where did the powers go? Where did the 13th power go? Well, we took care of it because we went ahead and divided by 4, found the remainder, and went through the whole cycle. Okay? If you were to go back to your first set of notes and have gone all the way next to the I to the 13th power, you'll see that I to the 13th is equal to I. So some of the algebra we're doing here should remind you a bit of what we did with functions. Okay, there's a minus right here, so I got to go ahead and distribute this minus to both of these terms inside these parentheses. So this is still negative 7 plus 8I. And this becomes a minus 3 minus 9I. And we combine like terms, so a negative 7 and a negative 3 is a negative 10. And then we have this plus 8I minus 9I is a minus 1I. However, we don't typically write that minus 1 in front. We just put it as a minus I. So on quizzes and tests and assignments, you'll see me write it more like this than with a 1 in front. But they are equivalent. Part E is great. I'm going to talk a lot more about this in the future, but I wanted to kind of start wrapping your mind around it. This is multiplication. You can distribute, you can FOIL. I'm going to use a box. Students keep telling me, Mr. Over, I don't get the box. I don't like it. I don't know what it does. You're just running away from your problems. Like, embrace the box. Be the box. Okay. This box is actually very helpful when we do more difficult problems in the future that require a lot of distributing. So I have a 3 plus 2i. I have a 3 minus 2i. 3 times 3 is 9. 3 and 2i is a positive 6i. That's an I, not a 2. And that's a negative 6i. And this is going to be a positive 4i squared. Great. I'm going to write these all out. That's a 9 plus 6i minus 6i plus 4i squared. Now you know that these two combine and they cancel out. I have 6 ice creams, but I ate 6 ice creams. Ice creams are gone. Haha, but we're not done yet. It never ends. Remember that we defined early on and have done so in every video so far that I squared is equal to -1. So wherever you see an I squared, plug in a -1. And so we do that here. And by the way, did I say plus? These should be minuses, so make sure you fix those. I think my pen got the better of me. So anyway, this was a net positive 2i minus 2i was a minus 4i squared. Okay, there you go. Minus 4i squared. Minus 4i squared. I squared is -1 by definition. So this becomes 9 minus 4 minus 1 is a plus 4. And that's equal to 13. How quaint that we would begin with such an ugly problem with i's and numbers and pluses and minuses, and then proceed to do a box with this, and then see some things cancel out, replace our I squared with a -1, and we end up with a actual number answer, a purely real number with no complex, no imaginary part. Interesting. Well, because you asked for it, let's go ahead and do it. Let's do some more boxes. Here's our setup for this one. So there's 2 terms in this one. I put them up here. And this binomial has 2 terms, so I put them on the side. Let's be careful with our signs. -3, negative I, that's an I to the 3rd power, plus 6i squared, and then plus 2i. Is this 2 times 3 or is it 2 plus 3? It's times. So we only add the powers, or do we? Boom, boom, boom. We only add the powers if we're multiplying. And what are we doing here? We're multiplying. So we added the powers. Okay. Now, let's write this out the long way. -3 minus I to the 3rd power plus 6i squared plus 2i to the 5th. Now, this is where it's going to be pretty handy if you have your other set of notes with all the powers of I that we did. Pretty convenient. We know, for example, that I squared is -1. What is I to the 3rd power? It's -I. What's I to the 5th power? It's I. So if you're like, where did he get all these things from? It's go back to those other set of notes where we did those, and if not, you can always divide by 4, right? You can take that 5, divide it by 4, the remainder of 1. You look back at your little table, remainder of 1 is equal to I. So let's clean this up. That's a -3 plus I minus 6 plus 2I. You better be careful of those 2's and i's or you're going to be in trouble. -3 minus 6 is a -9. And then we have the plus 1i, if it helps you, plus 2i is plus 3i. So expect to do crazy problems, right? Like problem E and problem F. They look ugly, they look horrible, but they end up turning into pretty tame answers. Nothing too convoluted, nothing too radical, no pun intended. It's right. For this last one, we're gonna go ahead and distribute this to everybody. You can box if you want, but it's kind of a weird looking box. This is a simple enough problem. I tend to box when I have pluses and minuses in between both of them. Like this one, right? This one has minuses and pluses, but the other one doesn't. So I to the 3rd times -1. And then I have a minus I to the 4th because this has a 1 power. and I do 3 plus 1 is 4. And then on this one here, the last one, that's I to the 7th power. Right? Because if you consider I third and I fourth, that's 3 i's from here. That's 4 i's from here. How many i's is that total? 7. And now we go ahead and use our little table or remainders or whatever you want to do. I to the 3rd power is negative I. I to the 4th power is 1. I to the 7th power is negative I. Again, expect this nasty problem to kind of just fizzle away, right? So we have I minus 1 minus I. I mean, if you want to put a 1 here and a 1 here, that's great, but it doesn't really matter because I have 1 ice cream, and I ate that 1 ice cream, and they're gone. So all I have left for my answer is negative 1. So this whole thing is equal to negative 1. Poof. For your summary, so obviously we've been using a lot of just order of operations, skills that we did in functions, skills that we did in Algebra 1 and pre-algebra, just a lot of little algebra skills combining like terms. But in light of what we just did in problem 2, we added some extra things that you need to be able to do with the imaginary unit. For example, when they have powers. So take some time to think about and write about what additional skills did we use with these problems besides your algebra skills that you already have.